How do workers in manufacturing stand to benefit from the adoption of these technologies? Can the IoT be used to, for example, positive things, prevent workplace injuries, limit workers' exposure to hazardous materials, et cetera? And what are some of the pluses, IoT for workers?
Sure, it's a great question. There are a variety of things that can be going on. For example, worker going through the factory. If you've been, for example, to an automotive factory, you see the robots going on. They're moving, they're working. These are carrying sometimes thousands of pounds. So they're very powerful robots, and you never let a human get close to them. But now you have the robot area, you have the human area, and the reality is now with IoT of things, and again, one has to be careful about, this issue of privacy and so forth, but I'm even walking down with my phone. I know where people are, so if somebody walks into an incorrect area, we can shut it down and make sure the robot, doesn't, hurt them, but even better, we can start to localize it better. It's a much tighter resolution, such that the robots can be working with the people. Robots are great, but they're never going to replace people completely. I mean, they're great at lifting really heavy things, but try and pick up an egg with one and so forth. We have great research on that, but again, working together is really where you leverage it. And by the way, it also allows us to get rid of a lot of the really nasty jobs. Your statement about taking away the sort of the terrible jobs, checking coolant tanks and lubrication tanks and machines. That's all automated. In fact, I was smiling. I was down in your cafeteria, and I saw your coffee containers, the coffee urns. They have the same technology that we're using now in there. It's about 50 cents and so forth. The only difference is ours are online, and so they're reporting the information. But we're talking with companies like Chick-fil-A and McDonald's about, how to do that for, improving their efficiency. So these are the types of things we see out there.
Well, I'm also very interested in keeping manufacturing jobs in the United States and bringing them back. And you wrote in your testimony that America's infrastructure gives us an advantage there. I'd like to hear more about that.
Sure. Well, if you look at everything from our roads, to broadband and so forth, and again, these are things that people really use all the time. Whether it's broadband you're wired into your factory or broadband over here, that capability and that growing of that capability allows us to take the big data generated by all of these different sensors, and in some instances, again, it's not just, well, I have a bunch of sensors, but in some instances I've got this phone with this really nice camera, and we have our workforce taking a picture. So now we're combining, right, the workforce that says, oh, this is good, this is bad, taking the picture, that brings it together, integrates the information together, but you've got to get that out, streaming all of the data, and it is a lot of data. And then, of course, the other infrastructure really is the educational infrastructure. If you think about the technology from even 5 or 10 years ago, it's old. So we've got to keep that workforce spun up. Lifelong learning, and that infrastructure needs to be put into place so that today's worker is still viable in 5 or 10 years.
Well, I was going to ask about that because the role of government, and certainly public education is a part of that, but there's also federally funded research, et cetera. So government does have a role to play then, doesn't it?
Oh, definitely. And all the way, again, from the K through 12 that we hear about education and so forth, to our bachelor's students, to our master's and PhDs. I mean, if you take a look at National Science Foundation, I was sponsored at MIT, right, as a National Science Foundation on a project there. A good chunk of our graduates, masters and PhDs in engineering, technology, and in science, are supported by the National Science Foundation. Again, that's something that you don't really see, but they're supported as research assistants. And this is a very important thing to move forward, the entire infrastructure for the nation.
I appreciate that. So I'm concerned because spending plans that we've seen from the Republicans make drastic cuts to many of these things and to programs that directly support manufacturing and innovation, including President Obama's Manufacturing USA initiative. So these cuts, I'm assuming, then could be a barrier to progress.
Yes, I mean, I think that what you have to look at, right, is in the short term, it's fairly easy to make a cut like this and so forth, but really the federal government, we don't have AT&T Bell Labs anymore. We don't have really long-range thinking companies. They're focusing on the here and now, and I don't blame them. Right? The federal government has to step in there and really do some of the longer range thinking. I guarantee you, China's doing it, Germany's doing it, you name it, other countries are doing it. We need to do it. So in 5 years, in 10 years, we're positioned to continue to move forward. This is really, again, what we really need to be looking at a little bit longer term, and that's what these R&D capabilities are all about that we're talking about.
I appreciate that, and I yield back, Mr. Chairman.
Digitally connected supply chains have the potential to be an important component of the industrial Internet of Things. Just-in-time manufacturing promises to drive down the need for storing excess inventory and allow suppliers to anticipate and deliver the materials manufacturers will need more quickly. Decentralized ledger technologies like blockchain can make supply chain transactions faster and cheaper by securely connecting manufacturers and suppliers in real time. I'd like to hear from Mr. Poonen and Mr. Kurfess, what are your thoughts on technologies such as blockchain and others, and its ability to play a role in IoT manufacturing and security?
Sure. So that's it's a great set of questions, and the reality is the distributed capability, whether it's blockchain, or any of these other distributed capabilities, these are going to be critical in terms of moving things forward. If I've got a supplier, only one supplier that supplies me with parts, and if I say tomorrow, oh, I need, I was at Toyota, how is it going there? And this is in Kentucky. And, they said, well, great, we've got, every 6 hours we can get, parts from Denso and so forth. We're very lean. We have, very small inventory. You go to Denso, well, how's that working for you? Well, we've got, 2 or 3 months of supply back there because we don't know what they're going to, what they're going to ask us. Now, they're starting to figure out how they're going to ask together, but imagine if instead of one big company, Denso, right, we had a bunch of smaller companies, right, that could supply this. So, yeah, if I need 500 parts, right, as opposed to one company say, can you make 500 parts? I could go to, 100 companies, local companies, mom and pop shops, and say, I need 5 parts. Or how many can you supply? 5, 10, here, there. And all of a sudden, you can bring that together. You not only can get those parts there, and by the way, you could use something like an Uber to make the delivery, right?
Right.
And so the infrastructure, again, back to the infrastructure, it's there to pull it off, right? But now you also have a very resilient supply chain. If one goes down, you don't have to worry about it. Turning that around as well on the educational side, you can take a look at what are these guys doing and, where do they need more training, and let's get them that training. We could even percolate that down into our colleges and into our high school levels so we can deliver the education to the workforce, and we can even start to send the right students in the right direction to really engage them. So lots of stuff distributed, all the way from supply chain of parts, but supply chain of our workforce as well.
Right,
thank you.
That's great, thank you. Let me go on to something quickly. The Clean Energy Smart Manufacturing Innovation Institute in California has been working to accelerate smart manufacturing throughout the country. Broad collaboration on the integrated tools and systems that are driving smart manufacturing will help reduce the cost of deploying these technologies. These partnerships and collaborations can also facilitate the interoperability of devices and standards. Mr. Kurfess, how can government and industry partnerships help develop tools and practices that will drive smart manufacturing adoption?
Well, so that's a great question, and I think we've already heard about things like,
Go ahead.
oh, I'm sorry, I have heard about things like standards and so forth, but really to help move this forward. The difficulty is, again, you get back to the distribution. There, different people want different, standards and different capabilities and so forth. When you start to bring these entities together. So, the smart manufacturing team that's, I think, centered in the Los Angeles area, they're actually, and it's not only the big companies, but it's also the so-called small and medium-sized enterprises, the SMEs, that they're bringing together. So they're really bringing everybody together to say, yeah, how does this move forward? How do we do this? And what a lot of the companies are getting is, yeah, I need to release this because to become more productive, more capable, right, I need to participate in this standard. It's like when I turn my, laptop on, the Wi-Fi, I know I'm going to be online. That's a standard, and that's really where we need to be going with manufacturing. And by the way, we need to do it. We see our, competition overseas doing it in a big way.
Yeah.
So, we've got to be cognizant of that. Thank you.
Well, thank you. This is all very interesting. I know we're out of time, but thank you.